Hey Bob, how you doing, sir?
You're doing well yourself?
I'm doing really good, staying busy.
Yeah, it's been a fun year. Things are changing and we're changing with them. We've got some new technology, a couple things to show you today.
Well, we've been longtime partners, and you've educated us on Cooney Coils enough for us to educate a lot of our customers. So it's an excellent product, and we always look for opportunities to apply it. Tell me just kind of the basics of the technology in case somebody is not aware of what it's all about, the general premise of the technology for our viewers and customers.
Sure. As you know, for years, we've had a lot of customers call with coils, fluid and steam coils,
Right?
that may freeze and rupture. When that happens, not only do you have to replace the coil, but the ensuing property damage or damage to the building can be astronomical.
Sure.
We viewed it as an epidemic years back, and with the prompting of one of our larger pharmaceuticals, came up with the freeze block technology. So instead of a bare return bend coil, we have fixed an expansion relief header and developed a micro pressure temperature sensing valve so that if this coil begins to freeze long before it's in danger of rupturing, it's going to sense there's ice forming in it and deploy a controlled volume of water, which not only protects the coil and actually freeze it and thaw it, it goes back into normal working condition, but it also protects the building. As you know, mold remediation and building damage can be astronomical.
Right. And just to be clear, we're not stopping the coil from freezing. It's still the water still freezes and follows the normal laws of physics. It's just that it doesn't create any damage.
Exactly. In this case, you're never really going to get 100% of the water out of a coil. And when you convert water to a solid, there's about a 9% increase in volume that's going to occur. That's what actually blows the return bends out.
Correct.
In our case, by deploying some of that water, we're going to make room for a freeze. Then when it constricts, it goes back into normal operating mode and we have no issue.
Right. And one thing people don't realize, but the amount of force that water or that expansion creates is incredible. It's thousands of PSI. So there's no way you could design a heat exchanger that can withstand freezing. It would be ridiculous. It would be infinitely large. So the better solution is to give that water a place to go.
Correct. Rather than reinventing the wheel with a titanium coil that's going to cost you 100 times the price of a copper coil, we wanted to stick with the industry standard materials, adapt to that, and find a way to prevent that rupture.
Right. And same as you, I've been in the replacement coil business pretty much my entire career. So I've seen, all kinds of freezes. It's when you see it a few times, you know exactly what it is. Those heat exchangers, they behave the same way. When they freeze, the way they pop open and stuff is always the same. So it makes perfect sense that you would allow that expansion to happen and the valves relieve the pressure. It seats back, correct, once the pressure is relieved.
Right.
And you're basically waiting for it to thaw.
Well, and if you think about it, when you walk into a mechanical room, almost every valued piece of equipment has a last line of defense, which is a pressure and temperature relief valve. You'll see it on your boilers, your water heater in your house, your heat exchangers, your steam pipelines. The coil was one of the most vulnerable items because no one had ever figured out how to put that last line of defense in.
Right.
Done that. So it's now up to par with the rest of the equipment in the mechanical room.
Makes perfect sense. And of course, just once again, to be clear, we're mainly talking about high percentage outside air applications and air handling equipment, right?
That's the number one, but we're seeing a lot of people actually start to put it in with mixed air that used to be of a lower percentage, but times are changing.
Sure.
With the pandemic, ASHRAE is now putting through some new standards and people are starting to size units to handle a higher percentage of outside air or to flush the systems out at night with 100% outside air to get so many air changes in a building. And as you know, what that does to your system,
Absolutely, yeah.
Dramatically increases the risk of freezing and rupturing.
Yeah, I've read the articles as well that ASHRAE is basically saying, hey, the best way to clean up a building, flush it after it's been occupied, and then flush it again before it becomes occupied again. So that means you're forcing your building into an economizer mode of sorts, right?
Exactly.
And so lots of systems out there, to your point, weren't designed for that. So you put it into economizer mode and you're really relying on a freeze stat or a damper working correctly. And as we all know, those things break all the time.
Well, mechanical failure and human error are the number 1 and 2 causes of failure. And what people don't want to do is go backwards and put glycol or antifreeze into a system. Years ago, they did that, but with the green movement and with energy being so focused on carbon footprint, they don't want to put glycol in and pay a 5 or 6% penalty to have that freeze protection.
Right, and so to that point, especially here in our southeastern climate, we have some really severe swings in not only weather, but what happens this year and next year. I mean, we may have a winter where we hardly ever get into freezing conditions, and then we may have a winter where we are in the teens for days on end. So I think what happens a lot is building owners, operators forget. They'll have some other system issue, something leaks out, they put water back in, and it runs great with no problems until you have a snap, and then all of that stuff freezes.
We call that the false sense of security.
Correct.
Where someone will say, oh, we use glycol. Okay, how do you maintain it? How often do you check it? Does it ever separate? And by the way, if it drops below a certain percentage, does it become corrosive and start to erode or thin the walls down of your tubes, which Absolutely. Then your coils fail because of another issue, which is
a whole other issue. Yeah.
Right.
So Bob, now that we've talked about the general concept of the Cooney valve, I understand that there's been some advancements and evolution in the technology. Can you tell me a little bit more about the smart coil technology?
Sure. Reliability was important. Green was also important to get away from glycol, but then smart. That's one of the big buzzwords in the industry.
Sure.
A lot of customers that have had coils freeze were delighted that they didn't rupture, but in many cases they never knew that it happened.
Right.
So the question kept coming to us, what can you do to alert us when we have an issue?
Right.
So what we did, it's really neat. We put a small plastic clip on the bottom of the valve and a 2-prong conductivity sensor that pops into that clip. Now, if that valve deploys, you'll notice this is the controller that cable's connected to.
Right.
Full width. A drop of water hits it and boom, you can see the light went off. That can be tied in with your building automation system to send a signal to your controller back to your control room to say, hey, shut the fan down, close the louvers, protect the air handler and the building.
Sure.
Give us a warning. Even make somebody's cell phone ring to let us know that unit's having an issue. And with that, they can go up, use some critical thinking, figure out what happened, fix a pneumatic tube or broken wire, down pump, and get back up and running. And in your replacement coil applications, they may not want to use this, they may, but a lot of the new air handlers. So when your customers call in and said, hey, we need a new applied air unit or a Munters unit,
right.
You'd like to get the freeze block coil, you can also promote the smart coil feature. And in most cases, people are embracing this, saying, yes, add that in as well. They want to know what's going on when they have an issue.
Absolutely, yeah. I definitely agree that, and there's lots of mission critical applications there where it's really important that the owner, operator knows exactly what everything is doing. So, Bob, it's really great seeing you, sir. Thank you for taking the time to chat with me about this very interesting technology. I look forward to seeing you very soon, hopefully at the next ASHRAE show next year.
It's always a pleasure. Let us know what we can do to help. We're here for you. Thank you.
Thank you so much.